like to talk about one last disturbance to equilibrium, and that's adding a catalyst. Um, so we've talked about concentration and volume and temperature, but if I have a reaction at equilibrium and I add a catalyst, what's going to happen? Um, well, so for everything we've talked about, we can kind of frame in terms of collision theory and think about what's changing about the number of approaches to the activation barrier or the amount of energy they have as they approach the activation barrier, all of these things. But catalysts lower the activation energy barrier, and they do it by fundamentally changing the mechanism. And so the mechanism is completely different, and it might have multiple activations now. But what's universal is that this activation energy decreases. And so it's both easier to overcome the activation barrier from our reactants to our products, and it's easier to overcome the reaction barrier from our products to our reactants. And so we actually see that when we add a catalyst, we lower the activation energy, but we actually equally affect the rate of the forward and the reverse reactions. And so it does not affect equilibrium at all. So our equilibrium will still be the same balance, even though the reaction will happen faster. And so this is kind of an important idea, is that just because the rate has dramatically increased for the overall reaction doesn't mean that the equilibrium, the balance between the ratio of products to reactants when we stop seeing changes has changed. That's a lot of change. Um, so uh, catalysts won't affect equilibrium. And that is my short video on that.